All right, part 2. Here we go. G of x is this and this, the piecewise function. So we're going to start with this little bugger. We're going to say, okay, if x has to be less than or equal to 0, I'm going to stick a 0 in here and -1 and just see where this goes. So 0 plus 1 is 1. -1, if I put that in there, would actually be the opposite of -1, which is 1. 1 plus 1 is 2. And I'm going to start with those 2 points. Now it says less than or equals, that's why I filled that in. It's something you have to think about. And then -1, 2 would be right here. And you can see if I typed in another -2, just for clarity, that'd be 2 plus 1 is 3. And so -2, 3, linear function, it would go on and on and on and on and on, forever that way. So, what about this? Well, we can see we have a parabola, because this is the parent function is y equals x squared. However, let's take it and follow this. X is greater than 0, so we're going to find out what happens at 0, and then 1 and 2, and go from there. So 0 squared is 0 times 2 is 0 minus 2 is -2. So, but that is an open circle, because it's strictly greater than 0, not equal to. 1 squared is 1 times 2 is 2, 2 minus 2 is 0. So that would go right here. And then 2 squared is 4, 4 times 2 is 8, 8 minus 2 is 6. So 1, 2, 3, 4, 5, 6. And again, we know it's a parabola, so it's going to be shooting up pretty quickly like that. All right. So, is it continuous? No. Why? Because there's a break right here. All right. So, moving on from there. Converting radians to degrees, degrees to radians. Well, remember, we've got a whole bunch of what we called automatics. Pi over 3 is 60. Pi over 6 is 30. Pi over 4 is 45. But remember, in our back pocket, we know that pi radians over 180 degrees equals 1. We also know that 180 degrees over pi radians equals 1, because they are equal. So, 210 degrees. Now, what I'm saying is we should use our automatics when possible. So I can see that 30 goes into 210 7 times. So I'm going to take its radians and just multiply it by 7. Those should be easy. These, a little challenging, because I can see none of these go into 111. That's pretty obvious. So I got to multiply this by either this or this. Now remember, this is 111 degrees, technically over 1. So I want the degrees to disappear, so I'm going to multiply by this one, because I see that the degrees are in the bottom. This is like a chemistry class. So those units disappear. So I am left with 11 pi over 180 radians. Now if we wanted to clean that up, I'm going to go 111 divided by 180, and I get 0.62 pi radians. Now if we wanted to go a little bit farther than that, we'd multiply that by 0.314, whoops, no, times 3.14, we'd have 1.93 radians. Okay. And that kind of makes sense, because remember, we said, I hope I said, that 1 radian is approximately 60 degrees. It's less than this. It's like 57 or 58. We could figure it out. But so 111 degrees is a little less than 2 radians, and looks like we nailed it. So a little common sense. So this one, again, pi over 3 is an automatic. Pi over 3 is 60. So this is just telling you 4 times 60, and so that'd be 240 degrees. This one's a little different. 7 radians. So I got 7 radians over 1, and I'm going to multiply it by this one this time, pi radians, 180 degrees. Well, I better put that in there. And I see the radians disappear, so I'm going to go 7 times 180, enter, divided by 3.14, 401.27 degrees. All right. So they just give us the graph of f of x is right here. They're saying sketch the inverse function. Well, if you recall, this, I guess we didn't really need this. I might clean this up a little bit. So essentially, what we're going to do is remember the old y equals x trick. So if I go y equals x right along here and here, and I understand that the inverse function is simply a reflection over that. It's very important when they give you a point like this, which is -3, 0, to remember if that's f of x, then the inverse function is just going to flip these 0, -3. That's kind of a locator point. So we have 0, -3, 1, 2, 3. This is always also a go-to point, and then from there, why doesn't that look right? Oh, I see. 1, 2, 3, 4, 5. Wow. All right. So 5. There we go. And now this would be something like that. And there's the sketch of the inverse function. All the x's and the y's are flip-flopped. All right, number 26. Number 26, for the parent function f of x or y equals x cubed, let's stop right there. Just throw a few values at you just to kind of get the ball rolling. If we cube all those, we get -27, -8, -1, 0, 1, 8, 27. I'm going to start here. -1 would be there, 1, 1 would be there, 2, 8 here, -2, -8. And remember what this kind of looks like. There it is. So it says describe first. So it's like, okay, what does that do? Reflects it over the x. What does the 2 do? That's a vertical stretch, making it skinnier by 2. What does that do? Moves it right 1, and that moves it up 1. Then sketch it. So, first thing we're going to do is flip it. So that would be this part right here would flip and kind of go like this. And this part right here would flip over the x and go like this. Now, why am I dotting it? Because we're not done. So, now I'm going to go to the 2. And it's simply going to be narrower, vertical stretch. Now we're going to move it right 1. So I'm going to take that blue one, move it right 1 to the best of my ability. Just try to duplicate it. There it is. And then for the grand finale, we'll go orange, go Rams. So we're going to take that green one, the locator point is right there, we're going to go up 1, and we're going to try to duplicate it. So there it is. All right, number 27 is classic algebra. Do not cancel these x squareds out. Factor, 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 factor. So we're going to find 2 factors of -16 and add up to -6, -8, and 2. Difference of 2 squares, x minus 8, x plus 8, gone, gone. That would be my final answer. Common denominators, so my common denominator is going to be xy, so I got to multiply this by y, so I got to multiply that by y. Got to multiply that by x, so I got to multiply that by x. So I get 3y over xy plus 4x over xy, which, if I put it in alphabetical order, 4x plus 3y all over xy. Almost done. So if g of x equals 3x cubed, what's the output if x is negative 2? So that's really just saying find g of negative 2. So that'd be 3 times negative 2 cubed. That's negative 8 times 3, which is negative 24 for part A. Now, I'm going to get a little tricky with you. What is the input, x, if the output, y, is 81? So we go back to that equation, put 81 in for y, which is just g of x, equals 3x cubed. Divide by 3, divide by 3. So I get x cubed is 27. We're going to take the cubic root, we can see that x would be 3. So there we go, that would be the input. Okay, next one, it says, what is the equation determining the input from a given output? Well, if we go to this, we know that that equals y equals 3x cubed. They want us to kind of flip things around. It's another way of saying inverse in a way. So what it means is we're going to solve for x. So divide by 3, divide by 3, we're going to get x cubed equals y over 3. But then we got to take the cubic root there, take the cubic root there. So we get x is the cubic root of y over 3. Now I don't know how particular they're going to be about this, but let's just talk about this. Technically, it's the same thing as the cubic root of y over the cubic root of 3. Now, it's been a while since you guys have seen this, but in order for us to get the radical out of the basement, if we multiplied it by only one of these, this would be the cubic root of 9, so that we would not get, that's not a perfect cubic root, so we'd have to add another one. And so we'd end up getting the cubic root of 9y in the top, and then this is the cubic root of 27, which is 3. Again, I'm not sure how particular they're going to be, but the answer for part C would be x equals the cubic root of 9y over 3. That's in simplest form. But they might have been content with this. Pre-calculus gets a little loose on that rule once in a while. Number 29. Find one positive and one negative coterminal angle with this. Well, that's the same thing as 10 times 60, which is 600 degrees. If we take away 360, it's the same thing as a 240 degree spin. I'm going to chew up a little bit of number 30 space for this one. And so 240 degrees with some accuracy would look something like this. So there's 180 plus 60, which is 240. Now notice I'm going in a positive direction. So if I just went around one more time, that would take me to the same place. In other words, we take 240, add it to 360. Whoa. Okay, I'm doing things backwards. This is my positive answer. I was going to take us back to the original problem, which is not good. So a positive 1 would be 240. So I already did it. So what's the negative 1? Well, a negative 1 would be going this way, which you can kind of chunk it out. That's 90 degrees plus 30 degrees, which would be negative 120. So there you go. Number 30, grand finale. A wheel, which is a circle, is spinning at 500 revolutions per minute. How many radians per second is this? So a good way to think of this is 500 revolutions per minute, and they're asking how many radians per second is this? Well, 1 revolution equals 2 pi radians. Same thing as 360 degrees. So we have 500 revolutions. That's going to be 500 times 2 pi, which is 1,000 pi radians. Now here's the twist, per minute. Well, how many per second is this? Well, there's 60 seconds in every minute, So we're going to take 1,000 pi, divide that by 60. Let me get my calculator out. 1,000 divided by 60, 16.67 pi. So if we multiply that by 3.14, that's 52.3 repeating radians per second. That's fast. That finishes your review, you guys. Good luck. See me if you have any questions.